Okay, this is example 2, and we should slowly but surely be getting a bit more comfortable. We had that long explanation about the Cartesian plane. We've had one example, second example. P is the point x minus 15 in quadrant 3. OP equals 17, making an angle beta. It should be beta, but I'm so used to saying beta. Beta with the positive x-axis. Determine sine cos tan of this angle. Okay. Remember, our first starting point. Let's have our diagram ready to go here. So we got this x, y, Cartesian plane. This Cartesian plane that you scribble is never going to have to be perfectly accurate. Probably would be worthwhile just drawing it with my invisible ruler here, but it's a vague scribble. Okay. P is the point x negative 15. Okay, so we know it's down here, but x, is x negative or positive? We don't know yet. From this part, we don't know yet. Then it tells us this, in quadrant 3. So our quadrants. Quadrants start up here in the top right. So in our top right quadrant, we can almost get there, up here, this is quadrant 1. Then we can go across to quadrant 2, then down to quadrant 3, and then across to quadrant 4, just above my head here. So I'm just going to put those in here just to remind ourselves. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Cast diagram, just in case we need it. All functions are positive here. So we go anti-clockwise with cast, because the quadrants go anti-clockwise. So it makes sense that cast also goes anti-clockwise. So we're going C-A-S-T. What does this cast thing do again? It tells us where a function is positive. All functions are positive up in this first quadrant over here. Then only sine is positive up in this second quadrant. In the third quadrant, only tan is positive. And finally, in the fourth quadrant, only cos is positive. Okay. We know that it's in quadrant 3. It's down here. So we can draw our point P. In the first video, I said it doesn't have to be perfectly to scale, but it helps to have a little bit to scale. But we don't know how far. X, we haven't worked out what it is. So it's going to be x along, and it's negative 15. And this length is 17. So I'm going to draw it just out in the middle of nowhere here. It's going to draw this line. Remember, point O is just the origin. This is P. What do we know about P? We know it's x, and it's negative 15. Is x going to be positive or negative over here? Yeah, it's going to be negative because it's on the negative x-axis. Okay. And OP equals 17. So R equals 17. And the first question often when you're given these is, draw a quick sketch of it, and then from there you go. Okay, so we got this angle over here. It says from the positive x-axis, there's the positive x-axis, make sure that's the positive side there. So going around there, this is angle, this time they've said it's angle beta. Right. When dealing with trigonometry, we always dealt with right angle triangles. So let's create our right angle. Notice how I make my right angle triangle over here. I don't add the line on this side. It's because we're coming around from this side, and it's going to help us. So we're coming from the positive x-axis and we're working our way around. And so let's do the same with our angle that this is within here. It just really makes a difference in how we go forward. So we're going to drop that line down there. This x value we don't know. This y value is negative 15, so that side length is 15. Hey, look at that, a right angle triangle where we're given two sides, and we don't know what this side length is here. So let's use Pythagoras. Okay, so our Pythagoras says that x squared plus y squared, which is negative 15 or 15, doesn't really matter because we're squaring it, equals r squared, 17 squared. So we go and we punch this Julia into our calculator, and we go 17 squared minus 15 squared equals 64. We square root 64 and we get 8. So we say x equals 8. Why not? Why is x not equal to 8? Oh, I hope that you're saying, well, hang on, we just said that it's negative. So x is negative 8. It's still going to work. Minus 8 squared plus 15 squared is 17 squared. X must be negative. There it is. It's sitting to the left. So it must be negative. Okay, so this value as x is negative 8. So let's put it in. Negative 8. Remember, big fan of what we got some information, put it in the diagram. Helped a lot with functions as we're going along there as well. Okay, so then we got all the information we need. Some of you might want to write down x, y, r equals over here. I'm not in this example. The diagram is quite busy as it is. Okay, so let's go from here. Purple, nice color, I think. Sine theta. If you asked to do three angles, the three trig ratios, I tend to go in order. Sine, cos, tan, because that's how we've done it. Soccer. That's how we've learned it. So let's just keep in that order. I can't have a giggle with that, but I would think of that video. Sorry. Okay, so sine theta. Now remember, we're not looking in terms of opposite, adjacent, hypotenuse. It's in terms of x, y, and r. So sine theta, opposite over hypotenuse, opposite over hypotenuse must be y over hypotenuse, y over r. So if we had it in this right quadrant, it would have been opposite over hypotenuse, y over r. Hey, look at this triangle. Can you imagine you looked at this little angle here? It still kind of works. It's the opposite over the hypotenuse. It's still y over r, whether you do it in the first quadrant or this quadrant. And it works nicely because we draw our triangle in this way. Remember I said draw it this way, don't draw this line along here. Draw it here. So then it's that angle there, still the one from the middle, opposite over hypotenuse. It's y over r equals 15 over 17. Cool. Cos theta. Cos theta. Well, that was y over r, so already we know it must be x over r, because it's also over r, it's also over hypotenuse. Let's look at this. If we imagined it, here's our triangle. It will be the same as that angle. It will be adjacent over hypotenuse. So this one must be x over r. You could have gone shade your rear because x-rays, blah, blah. You could have imagined the first quadrant. You've drawn that little sketch. Drawn that little sketch to go, duk, duk, there it is. I know that this is y, x, r, there's theta, so it's opposite. There it is. How long did it take to do that? Okay, so we're getting into this. And not apologies actually. Putting all those little tidbits in there because some of them are going to work better for some of you and some for others. So yeah, I'm always interested in which bits work well for you. So please keep telling me which ones. Okay, so x over r. So our x value is negative 8. We put it here. We didn't have to go hunting around here somewhere. It's in our diagram. Negative 8, our r value hasn't changed. And tan theta we can squeeze in here. And tan theta is, I kind of just start getting into the motion. Once I've done a few, I go y over x. Let me just double check. Was it y over x? Well, this isn't theta, but it's going to work out the same because we drawn our triangle. It's going to be opposite over adjacent, y over x. Yeah, it works. So trust yourself and then check it. Okay, y over x. Well, y is 15, right? It's not 15. Here's going to be a nice check, right? 15 over x is negative 8. Right. Now, things aren't going to feel good here. Remember, like with the a value, always think, was a positive or negative when it was in functions? Let's go back and just check our thinking. And we're going to look at our cast diagram. We're in the third quadrant. There's only one trig ratio that's meant to be positive over here. And that one trig ratio that's positive in the third quadrant is tan. Yet sine is positive, cos is negative, cool, that seems good, and tan is negative. Something's very wrong here. Okay, so what's gone wrong? I wonder if some of you spotted it and went, why did he write y as 15? Now here's why I made that mistake, and I'm leaving it because actually I didn't plant this mistake to go, you see, you could make a mistake, and people do that. No, sorry, I'm too upfront for that. I genuinely made this mistake, and now my little check, and I realized that here is going to help me. I took 15 because I read 15 over here. And I've been dealing with 15, but there isn't a 15. This length might be 15, but actually it's probably a bit unsafe to write. Maybe I should have said minus 15. Maybe over here we should have written negative 15. Then we're not going to make that mistake of there being a 15 somewhere in the diagram, because there isn't. There's a side length of 15, but it isn't 15. And look, I genuinely made that mistake there. So this should have been negative 15, because I should have read the point from here, but I saw a 15 here and I put it down. As I said, a genuine mistake. Let's check our others now. Negative 8, well, there was only a negative 8. 17, R is 17. 15, hey, I wouldn't have made that mistake twice now. Well, I did, but I picked up the second time and went, oh, okay, well, a negative divided by a negative is a positive. This is 15 over 8. A positive tan in this quadrant should be positive. And maybe somewhere there in the back of my mind, I thought, third quadrant, tan negative, just something, didn't feel quite right. Tan could be negative down here in this quadrant. Let's see if I can get my invisible maker here in quadrant 4. But it definitely couldn't be negative down here. So just those little checks. As I said, genuine mistake, leaving it in there. Okay, I think the point's made. Okay, let's keep going.